Ever pondered why NAND and NOR gates are prevalent more so than AND and OR gates? It's not by chance or a simple preference. There's a technical rationale behind this dominance, and it lies within the conductivity of pMOS and nMOS transistors. We need to delve a bit into the world of digital electronics. The building blocks of digital circuits are logic gates and or not, NAND, NOR, XOR, and XNOR. These gates have a critical role in creating any digital circuit you can think of, from the simple alarm clock by your bedside to sophisticated supercomputers. Now, all these logic gates are made up of electronic switches known as transistors. There are two types of transistors, pMOS and nMOS. Each has its own unique properties and behavior. The pMOS transistors are good conductors for high voltages, or in digital terms, the binary one. On the other hand, nMOS transistors conduct low voltages, or the binary 0, efficiently. Here's where it gets interesting. AND OR gates, when constructed using these transistors, require more components. This is due to the fact that pMOS transistors don't conduct zeros very well, and nMOS transistors don't conduct ones very efficiently. To overcome this, AND and OR gates are designed using NAND and NOR gates respectively, along with an inverter. So instead of designing an AND gate from scratch, it's more efficient to use a NAND gate and simply add an inverter at the end. The same goes for the OR gate, where it's more practical to use a NOR gate with an inverter. This approach reduces the number of components needed, making the gates smaller and more efficient. Output. Indications. In conclusion, the prevalence of NAND and NOR gates isn't random. It's a deliberate choice driven by the need for efficiency and the unique conductivity properties of pMOS and nMOS transistors. By utilizing NAND and NOR gates, digital circuits can be created with fewer components, making them smaller, more efficient, and more commonly found in our digital world. So, the next time you use any digital device, remember the tiny NAND and NOR gates working tirelessly behind the scenes.